Hello APC Mechanics students in Unit 1 Kinematics, Class 19, Projectile Motion, Part 5. Section 1, Trajectory of a Projectile. We have stated previously that the trajectory of a projectile is a parabola. Given the following projectile, it's being launched with an initial velocity v0 and it can be decomposed along the x-axis and the y-axis. In this section, we will derive the trajectory equation. This work holds for both symmetric and non-symmetric projectiles. We're not gonna put any conditions regarding the type of the projectile. And the position time equations are given by that, taking into consideration that the positive y direction is chosen to be up. Now let's suppose that the initial horizontal position coincides with the origin. And this might always happen, like 99% of the cases for a projectile. However, I left the vertical position to be y0. Then if this is 0, we're gonna have the following equation, and we can isolate the value of t in x. Then t would be given by x divided by v0 cosine theta. And now let's replace the expression of t obtained here in the vertical position. Then we have that t is given by x divided by v0 cosine theta. It can be replaced here and it can be replaced here as well, keeping the vertical position untouched, and we're gonna have the following equation. Now v0 with v0 cancels, sine over cosine would give us tangent theta. The power 2 is for both the numerator and the denominator, and we're gonna have the following expression. Then the trajectory equation is given by a relation between y and x. This tangent theta and all of that would be constant for a projectile, which makes this is a complete relation between y and x and no other parameter, which is an equation of a parabola opened downward. Now what are some interpretations or properties? It is linear in y and quadratic in x, which makes it a parabolic trajectory. A is constant in magnitude and direction, pointing downward, and this we know because we know that acceleration is due to gravity and pointing downward. However, we know that always a trajectory is characterized by how v and a are related. However, in this case, a is making a fixed direction downward, while the direction of v along the trajectory changes, which means the angle between v and a continuously changes and depends on the initial launch angle. Now, exercise 1, the velocity of a projectile at launch has a horizontal component vh and a vertical component vv. Air resistance is negligible when the projectile is at the highest point. We know that at the highest point, the only thing which is being affected is Vv is set to be 0, Vh is constant, and the acceleration is g. And we're talking about here in this case vertical acceleration or acceleration as a total. Which of the following shows the vertical and the horizontal components of its velocity and the vertical component of its acceleration? Then we're interested in the vertical horizontal components of the velocity and the vertical component of the acceleration. We know that the horizontal velocity would be vh unchanged, which leaves us with this. So we can directly eliminate this because we have vh. So we can ignore this and we can ignore this. And we know that the vertical acceleration is g. So we can ignore this, and the correct answer in this case would be E. And indeed, at the highest point, the vertical velocity would vanish. A ball is kicked from the ground with an initial speed v0 at an angle theta above the horizontal. Which of the following best describes the magnitudes of the velocity and acceleration of the ball when it reaches highest point of the trajectory? So the velocity, here we're talking about the complete velocity at the highest point. So we know that v is given by, at the highest point, v0 cosine theta, that would be vx. And vy would be 0 at the highest point, which makes the total velocity to be the Pythagorean sum of this and that, which means the radical vx square plus vy square, which means it is a radical of vx square plus 0, and that would be vx, because the radical cancels with power 2, and that would be v0 cosine theta. Then the velocity at the highest point, we are talking about the total velocity, and not the vertical velocity, would be v0 cosine theta, which means it's either this or that, but we know that the acceleration is always turned on and it's given by 9.8 meter per second square, and then the correct answer is D. Then the final exercise for today's video is given by, as an exit ticket, exercise 3. Two stones represented in the figure above are thrown from the same height with the same initial speed. So then basically this is an initial speed v0. Remember that in the previous video we have mentioned something, that the impact speed is given by two cases. Case 1, in which the object is left freely, then the impact speed is given by radical 2gh. And case 2, if the object is launched with a speed v0 independent of the direction, then the impact speed would be given by radical 2gh plus v0 square. Then in this case, both A and B, if they admit the same initial speed, they will hit the ground with the same impact speed. Now let me repeat and say, stone A is thrown vertically downward and stone B is thrown horizontally. Alright, if the stones are thrown at the same time and the resistance is negligible, which of the following is true? If you check the choices, they're discussing the time and the speed, so we know that the speed must be the same. Then let's start eliminating. Greater speed, this can be eliminated. Okay, we can keep D, we can eliminate C, we can eliminate B. Now the correct answer in this case is that stone A will reach the ground first. That would be the correct choice, and let me explain it. Now you can ignore the motion along the x-axis and just consider the motion along the y-axis. Now although this is gonna follow a parabolic trajectory, but you can think about it falling in this way. And similarly for A, okay, A will be thrown downward. Now both of them will be accelerated upon gravity. However, because A has been given an initial speed, that would make it cover the vertical distance faster. Then the correct answer is D. Then that's it for me in this video, guys. See you soon in a new one.